All right, welcome. Today we're going to do something a little different. We're not just going to learn a bunch of dry terms. No, we're actually going to build something. Think of it as an experiment machine, a machine whose only job is to find out what's really true.
So, let's just start with this big question. How do you really know if an idea works? I mean, not just feel like it works or hope it works, but actually prove it beyond a shadow of a doubt. How do we separate a good idea from what's maybe just a good story? Well, the answer is simple, but it is so powerful. You build an experiment. It's truly the best tool humanity has ever designed for finding the real cause of an effect.
And that's exactly what we're going to do in this explainer. First, we'll go on our quest for cause. Then we'll gather the core ingredients. After that, we'll get into the nitty-gritty of designing for truth. We'll take a quick tour of designs, and finally, figure out how to judge the design we just built. So, let's get to it.
Okay, first up, the quest for cause. We're moving beyond just seeing what happens to understanding why it happens. You know, it's so easy to see two things happening around the same time and just assume one causes the other. But to find the real why, well, you need a very special kind of tool.
And that brings us to this key difference. On one side, you've got an observational study. That's where you're just a spectator. You're watching the world go by, looking for patterns as they naturally happen. It's great for suggesting a link, but that's all it can do, suggest. But on the other side, you have an experimental study. This is where you get your hands dirty. You deliberately introduce a change just to see what happens. You're not just watching anymore, you're actively testing. This is how we get to the cause.
So, if we're going to build one of these, where do we start? Well, let's look at the core ingredients. Think of these as the blueprints for any experiment you could ever want to build. Every good machine, every good experiment is built from these essential, non-negotiable parts.
Ingredient number one, it all starts with a hypothesis. You know, this is just your core question, but stated in a way you can actually test. So instead of a vague idea like music might help sales, you make it super specific. For example, playing classical music in a coffee shop will increase average customer spending. See that? It's a clear, testable claim. We can prove it right or prove it wrong.
Next up, you need your independent variable. This is the one thing and only one thing that you're going to deliberately change. It's the cause part of our cause and effect equation. In our coffee shop example, the independent variable is the music. Are we playing classical or are we playing nothing at all? That's the change we're making.
And of course, if you change something, you need to measure what happens next. That's your dependent variable. It's the outcome, the effect that you're looking for. For our little coffee shop, it's pretty simple. The amount of money customers spend. So we're testing if the music, our independent variable, has any effect on spending, our dependent variable. Simple as that. Okay, we've got our parts list. Now for what is maybe the most crucial step of all, designing for truth. We have to build a fair comparison. This is where we construct our experiment in such a way that it can actually withstand doubt and eliminate all the other possible explanations for our results. Because, and here comes the villain of our story, uncontrolled variables. These are all the other things that could be messing with our results behind the scenes. Think about it. The weather outside, the specific time of day, maybe there's a big festival down the street. All these little factors can introduce noise and bias, and if we don't account for them, they can totally wreck our experiment. So the big question is, how do we fight back? How do we protect our experiment from all these hidden forces so we can isolate the one thing we actually want to test?
Well, luckily we have an amazing toolkit for this. First, you need a control group. This is your baseline, the group that gets nothing new, so you have something to compare your results to. Make sense? Second, and this is the secret sauce, it's randomization. You randomly assign subjects to your groups, and what this does is it magically spreads out all that weird unknown stuff, all those hidden forces evenly, so they basically cancel each other out. And finally, there's something called blocking. This is what you do when you already know about a difference, like say, weekday customers are different from weekend customers. So you group them together first to make your comparison even sharper. Let's actually put this all together and build our coffee shop experiment. Step 1, create the groups. We'll have our classical music group and our no music control group. Step 2, randomize. We'll randomly assign which days or which hours get the music and which don't. This is absolutely key. Step 3, apply the treatment. We play the music according to our random schedule. And finally, Step 4, we measure the outcome. We just compare the average spending between the two groups and see if there's a real difference. Awesome! We've built a basic machine. Now let's take a quick tour of designs because there really is a right tool for every job. Once you get this core logic down, you start to see that experiments can be shaped and adapted for pretty much any situation.
So, that coffee shop test we designed, that's a classic field experiment because it's happening out in the real world. But what if you can't randomize? Like, say you have to use two different stores that already exist. Well, then you'd use a quasi-experimental design. It's not quite as clean, but it's still really powerful. And what if you want to get fancy and test both music and new lighting at the same time? That calls for a factorial design. See, each one is a different blueprint for a different kind of problem.
And get this, you can even run a really powerful experiment with just one subject. It's called an N of 1 design. Basically, you repeatedly apply and then remove a treatment for a single person over and over. This lets you establish a cause and effect relationship that's totally personalized to them. It's incredibly useful in fields like medicine or even for figuring out your own personal productivity hacks.
All right, our machine is built, the experiment is done, time for the final critical step. Judging the design. Was it actually a success? We've got to inspect our work and be really honest about whether the results are truly trustworthy.
And this brings us to a classic trade-off. We have to ask two big questions. First, internal validity. The question here is, did the experiment actually work? Is our conclusion that the music caused the change in spending justified within this specific study? Then there's external validity, which asks, does the experiment even matter? In other words, can we take what we learned in our one little coffee shop and generalize it to the real world of all coffee shops?
Ultimately, what we're looking for is a high yield. That's really the measure of the overall quality of our design. Put simply, it's how much trustworthy insight did we manage to get for the effort we put in. If our coffee shop experiment gives us a crystal clear, reliable answer after just a few days of testing, well, that's a high-yield design. And the ideal state, the perfect world that every experiment designer is dreaming of is this: zero confounding. It's this perfect hypothetical condition where all those annoying outside influences are totally controlled or randomized away. Now, it's pretty much an unreachable goal, but it's the North Star we navigate by. It's what pushes us to make sure the only explanation for what we see is the one thing we actually changed.
So there you have it. We've built our machine. We know how to hunt for the cause, gather the parts, design it for truth, and judge its quality. So now the real question is for you. Think about your job, your hobbies, your habits. What's one thing you believe is true that you could actually build an experiment to test for yourself?